Hello all, in this video we will talk about the program which is written for interfacing Arduino Uno board to MCP3208 ADC. So this is just a basic explanation. You can dig deeper. We will post this code on our blog. You can visit our blog and take it if you want to work on it. So if you see here, these are the pins, the SPI pins that come out. So we will post in the video later at the end of this video, towards the end of this video, where we have shown how we have connected. So you can just check out. We have used Arduino sensor shield there, and then we have two variables that are declared ADC input and output data, and then there's a function. So this is an extract of the SPI code that is there in the Arduino website, and then it is modified, but tinkered a lot based on the datasheet requirements of MCP3208. So if you see, this is how the SPI transfer function is written. It's nothing complex here. So we are just trying to push the data to SPDR and checking until the transmission is completed or not, and then we are just trying to return whatever the data that is being received. So a simple function, nothing complex here. If you read the Arduino Uno data sheet, you can get to know this functions. And then in the setup, we are using a serial port to push out the ADC data that is written, and then the pin modes are set, like data out, which is MOSI, master out, slave in, is set as output. MISO, which is master and slave out, is included as input, which is basically the output from the slave, and then SPI clock is output, select is output. So these are the pins, and then we are just initially disabling the device that we activate the device from a known state, and we are initializing the SPI. So what we are doing in that particular function is nothing great. Again, we are just disabling the SPI interrupts and reading continuously in a polling method, and then we are basically reading MSB first, and then and also we are enabling the SPI. Okay, and another important thing is we are keeping the clock low when there is no activity. So these are the basic things, and you can see the system clock by 4 is the clock which we are using here. So these are the functions that are set. So if you go through the manual of 18 mega 328p, you can get to know these registers and settings. And then once that is done, we are basically taking this chip select low, so that we have the chip select low, and the chip is activated, and we are doing SPI transfer 06. So you see the datasheet of MCP3208, so they are clearly given the interfacing of SPI to this chip. So if you see here, initially chip select is pulled low, and there are few clock cycles. These are idle clock cycles where data in is low. So that means there are 5 clock cycles which are low, and then post that we are giving a start bit, and this is single or differential. So like if you see MCP3208, it supports differential. So these channels basically supports either 8 single-ended channels or 4 differential channels. So that's the configuration we can make. So if we go to this particular data sheet, you can see the configuration here. So if we make the single by differential as 1, all these channels act as single-ended. Now if you make the single by differential as 0, all the channels act as differential, and that means there are channels which you like you can use them only as different and not single-ended. That means you have restricted channel access, right? Lesser number of channels. Now that's what it is said, and then we have connected our chipset to the our analog input to the channel 0. So that means D2, D1, D0 must be 0. So if you see here, D2, D1, 0 will be 0, and then there will be some dummy data that will be sent, and this 12 bit of data will be read by the master, which will be output by the slave. That's how the operation is. Now, if we go to how we have written, so you can see here the SPI transfer initially there are clocks, and then there is a high bit, and then there is a single by differential. So which, if you see from the data sheet, so these MSB bits are zeros, and then this will be 0, this will be 1, this will be 1 as we discussed, and again D2 will be 0. That means 06 is the initial byte, and then if you see the second byte 0, 0, and these are don't get, so we are keeping it 0. So that means we have to send 06 initially, and then 00 to start reading the output from the MCP3208. So you can see here initially we sent 06, and with some delay we have sent 00, and post that we are immediately reading, because once you send 00, right, we have to read the data. So if you go to the read function, we are doing nothing but we are just trying to send some FF and just try to read the data there. So that's what we are doing here. Okay, so that's what we are trying to read, and then we are printing that in decimal format on the output, and post that we are making it high, the chip select high, and then again we are enabling the chip select, post that again we are continuing the sequence 0600, and then read the data again output. So this is put in a loop. So that is why if you see on the serial monitor, you can see there is a data that is continuously output. Now we are changing the input here. You can see there is a change in the data. You can see the data is continuously changing based on the pot variation that we are doing. So we will see how the connections are done from the Arduino side. Here is the board with the connections. So if you see here on the right, there is a Arduino board with the sensor shield mounted on it, and then from there, using the SD connector, we connected those pins. So this is the SD connector. From those, the SPI signals are connected to MCP3208. This is the MCP3208 board, and then through a port we are giving the connections to one of the channels of MCP3208. You can see the connections here, and then if we see, you can see we are continuously reading that particular channel, and you can see the values. Okay, you can see we changed the port and the value got changed. So the interface looks like it's working well.